Hello, this is O'Morgan from omorganlabs.com. Today we're going to be talking about atomic number, mass number, atomic mass, and charge. Basically, you'll come across these concepts when you're trying to figure out molar mass or you're trying to combine elements into compounds. So today we're looking at lithium. First off, you have this notation with charges, atomic number, and mass number. You'll come across this notation when you're combining elements into compounds. So the first thing, atomic number, that's going to be the number of protons. It's going to be on your bottom left-hand side. This basically is your address of the element. If you have 3 protons, you have lithium. If there are any other numbers for protons, you have a different element. It has to be 3 protons. That's the address for your particular element. Next would be your mass number. Okay, mass number is going to be in the top left-hand side. Okay, it's going to be right here. This is your protons plus your neutrons. This is important because depending on what you're talking about, which element you're talking about, you need a certain isotope. These are called isotopes when you have different neutrons for the same number of protons. Like uranium, you need a particular type of isotope of uranium to have a nuclear reaction. Okay, so it's important. So for this one, we have our 3 protons, right? That comes from our atomic number. But protons plus neutrons, they have to equal 7. So that means we have 4 neutrons in the nucleus. So we have 3 protons, 4 neutrons. 3 plus 4 is 7. Pretty simple, huh? So let's go back. We have something called the isotope form. Sometimes people will say lithium 7, uranium 238. I hope I have that right. They'll say things like that, but that just means that your mass number's right there. It means you have 4 neutrons for this particular element. Just other notation that you may see out there. Okay, let's go back to this notation we're trying to decipher here. Charge is going to be top right hand side. It's going to be your protons plus your electrons. Now this is a little tricky because when we say charge, we don't mean the amount of coulombs, right? You kind of think of electrons, you think of, okay, I have so many coulombs per electron. That's not how it works for this particular case. We're using unit charge. Okay, so 3 protons have a +3 charge, and you're left with +1, so you have 2 electrons. Electrons carry a negative charge, so 3 minus 2 is +1. So this would be your proton electron configuration of your atom. Like I said earlier, we use this when we're combining elements to make compounds, molecules, things like that. Atomic number, atomic mass. We know atomic number. We know that's 3. In the periodic table, you'll see it kind of like this. It'll be on the top. The atomic mass will be on the bottom. This is how many grams you have in 1 mole of lithium, 6.941 grams. And a mole is 6.022 times 10 to the 23rd things that you're talking about. So this would be 6.022 times 10 to the 23rd lithium atoms have a mass of approximately 6.941. So how did they get this number, you ask? I'm glad you asked. Say you had a sample of lithium and we figured out, okay, we're going to divide up the isotopes of lithium in this beaker of lithium. And however we have it, we have 5.9 and 94.1. We add them together, a weighted average, and we get to 6.941. Okay, so it's the atomic mass is the weighted average of isotopes or the molar mass. Okay, there you have it. Atomic number, atomic mass, and charge. Hope you enjoyed it. Please subscribe. Omorgan Labs.